We looked at ways that you can evaluate limits graphically. Now let's look at ways that you can use a calculator to evaluate limits. Consider the function f of x equals tangent of x over x. And this is a graph. As you can see, it has a lot of asymptotes, and at x equal to 0, we have an open circle here because the function is not defined when x is 0. We would be dividing by 0 here. And I'm interested in finding the limit as x approaches 0 of tan x over x, and I'll look at that same limit coming from the left, from the right, and then overall. So looking at the graph, you might guess that the limit would be approaching 1 here as x gets close to 0. So let's see how that might work by evaluating the function at different values on a calculator. So I'm going to make a little chart here. I have x and then I have f of x. And I'm going to look at values coming from the left, like -1 and then -0.1 and -0.01 and -0.001. And then from the right, 1, 0.1, 0.01, and 0.001. And then we have 0 in the middle. So at -1, I have this value, and then I'll just fill in the other values here. And you can see that it does appear to be approaching 1. And then also from the right, it also appears to be approaching 1. And remember, the limit doesn't care about what happens right at 0, so I'll just leave that blank. And then based off of this information, I think it's pretty safe to say that indeed all of these limits over here are 1. Since we have the left hand and the right hand limits both equal to 1 and they exist, then we know that the overall limit must also equal 1. Okay, so that was pretty straightforward. Let's look at another example. How about f of x equaling the square root of x squared plus 4, and then minus 2, and then all that over x squared. And I want to look at the limit as x approaches 0 of this function. So this one's a little more complicated, and we'll start by looking at the graph. So it looks something like this. Now, I know that at x equals 0, there should really be an open circle here, and I didn't put that in the graph here. If you were to graph this on a calculator, you'd probably get a graph that looks something like this. It's not going to have the open circle explicitly placed there. So that's why I didn't put it in this graph, but it is there. Okay, so now let's look at a chart of x and f of x, and these are values that you would evaluate on the calculator. So for x, I'll have plus and minus 1. I'll do both at once because in the function itself, we only see x squared. So the value that you get for 1 should be the same as the value that you get for -1, because when you square it, it's going to end up being positive anyways. Okay, so you evaluate that, you get 0.236068, and I'm going to carry it out to 6 decimal places here. And then plus or minus 0.5, we have 0.246211, and then plus or minus 0.1, and you can see the rest of these here as we get closer and closer to 0. And so it looks like it might be approaching 0.25. And if you look at the graph, that does seem to make sense here. It looks like that's what we are approaching here. So it looks like this is about a quarter here. And so that's our guess based off of the information we have in the graph. And everything seems okay. But now consider this. So we said that the limit looks to be about 1/4. Well, I'm going to keep going here. So I stopped when I was at plus or minus 0.01. Let's keep going and evaluate for even smaller values of x. So something like 0.000005. Well, you'd think it should get closer to 0.25, but that doesn't seem to be happening. And then if I use 0.00001, then I only get 0.2, and things get worse here as I get smaller and smaller values of x. So your calculator, if you were to actually try this yourself, you might get different values depending on how your calculator works, but you probably will see the same effect. It looks like something's happening here. We thought we were pretty confident it was 1/4, and now something strange seems to be happening. So does that mean we were wrong before? The limit is not 1/4? Well, it actually is 1/4. What's going on here has something to do with the way your calculator works. So let me show you by taking the graph and sort of zooming in close to x equals 0. Okay, so we have our function, and this was the original graph that we had. Now I'm going to zoom in. So if you zoom in enough, you get something that looks like a straight line, and it does still seem like the limit might be 0.25. But then if I zoom in even more, I get this strange graph here, and if I zoom in again, I get this kind of thing going on. So what's going on? Well, as x gets really, really small, the square root of x squared plus 4 gets really, really close to 2. And if you look at the function here, we are taking the square root of x squared plus 4 and subtracting 2 from it. And the calculator is having a hard time dealing with this subtraction here because these numbers are so close together. Eventually it just ends up calling this thing 0 up here. And that causes problems then when we're getting really, really close to 0 with x here, because we know that that's not quite what's going on here. We know that actually the limit should be 1/4. This is called a subtraction problem. It's when you're trying to subtract two quantities that are very, very close to each other and your calculator is having a hard time carrying out all those decimal places. Okay, let's try another example. How about f of x equals the sine of pi over x? And rather than starting with a graph, I think I'll start with a table this time. So the limit that I want to look at is the limit as x approaches 0 of the sine of pi over x. And I'm going to look at values of x and f of x coming from the left first. So these are my values, and I'm going to get closer and closer and closer to the 0 from the left. And when you evaluate the function at all of these different places, you end up getting 0 every single time. So, okay, this looks pretty good. It looks like maybe potentially the limit is 0, and let's, just to be sure, check from the right. So I'm going to do the same thing, make the same chart, except now I'm going to start at 1 and get closer and closer and closer to 0. And if you do this, evaluate at all these different places, once again, you get 0 everywhere. So does that mean then that this limit here is 0? So well, as you might guess, there's another problem here. So in fact, no, this is not the case. No, the limit is not 0, and let's figure out why. This is another problem that your calculator is having. Okay, so what's going on? Well, the limit as x approaches 0 of sine of pi over x. Here's the graph, and you can see that something strange is going on near the origin. And as we get closer and closer to 0 on the x-axis, this thing starts oscillating wildly back and forth. And we know that right at 0, we have a problem. We can't divide by 0 here. It's undefined there. And so this graph is just bouncing back and forth between 1 and -1, but never settling in on a number. So this limit, in fact, does not exist. It just kind of keeps going back and forth and back and forth and back and forth. So what's going on here? Well, this is a sampling problem. The values that I chose in the charts on the previous slide happen to give a value of 0. Well, look at what I was choosing. I was choosing 0.1 and 0.5 and 0.01 and things like that. And if you think about feeding those values into the function, you're going to get things that evaluate to 0 everywhere. So I just happen to be picking numbers that led the value of the function to be 0. If I had picked maybe some weirder numbers instead of 0.1 and 0.5, I'd pick something a little bit strange and then plugged it in, maybe I would have seen it's not 0 all the time. So what's the lesson here? Well, you can use a calculator to evaluate limits, but you have to be careful. There's two things to watch out for, the subtraction problem and the sampling problem. And the best thing to do, if you have to use a calculator, is to look at the graph and look at a chart of values and try and use all the information you can to determine the limit. Now, using a calculator is fine, but it does have its limitations. Later on, we're going to develop techniques that will help us evaluate the limits without having to use a calculator.